World's first nuclear diamond battery of its kind could power devices for thousands of years. The world's first nuclear diamond battery uses carbon-14, which has a half-life of 5,700 years to power devices. Oh my god. For thousands of years? That is crazy. By the way, carbon-14 is considered an unstable isotope of carbon. It's radioactive too. So it being in devices, I don't know how safe that is. I'm pretty sure if they're going to use this battery, it's not going to be for the public use or the everyday uses. So it's probably going to be for space stuff mostly. So let's read this and see. Maybe I'm wrong, okay? So the world's first nuclear-powered battery, which uses the radioactive isotope embedded in diamond, could power small devices for thousands of years, scientists say. The nuclear battery uses the reaction of diamond placed close to a radioactive source to spontaneously produce electricity, scientists at University Bristol in the UK explained in a Dick 4 statement. No motion, neither linear nor rotational, is required. That means no energy is needed to move magnets through a coil or to turn an armature within magnetic field to produce electric current, as is required for conventional power sources. The diamond battery harvests fast-moving electrons excited by radiations, similar to how solar power uses photovoltaic cells to convert photons into electricity, the scientists say. So this is kind of like, do you know how they take like the energy from the sun and then turn it into electricity? It's kind of the same thing going on here. So you have like a diamond and you have a radioactive carbon-14 here, and it's basically, can I move this please? Why isn't it moving? I have to move it very slowly. There we go. So you know how we have solar panels, which are like the little thingies that take the power from the sun here, right? And then here we have like energy. Same goes for this. So you have diamond. So this is your diamond here. So you have your diamond, and then you have here carbon-14, which is the isotope, which is radioactive, and then kind of does the same thing. And this diamond harvests the energy from the carbon-14. Let's go back to this. So scientists from the same university first demonstrated a prototype diamond battery, which used nickel-63 as the radioactive source in 2017. In the new project, the team developed a battery made of carbon-14 radioactive isotopes embedded in manufactured diamonds. So you know how there are like the normal diamonds that you find occurring in the world, and then you have like the manufactured diamonds, which are way cheaper than normal diamonds. They basically use that. The researchers chose carbon-14 as the source material because it emits short-range radiation, which is quickly absorbed by any solid material, meaning there are no concerns about harm from the radiation. Although carbon-14 would be dangerous to ingest or touch with bare hands, the diamonds that holds it prevents any short-range radiation from escaping. Okay, so they fixed that issue. So now we don't have to worry about the radiations. That is good. Diamond is the hardest substance known to man. There's literally nothing we could use that could offer more protection, Neil Fox, professor of materials of energy at the University of Bristol, said in the statement. A single nuclear diamond battery containing 0.04 ounce 1 gram of carbon-14 could deliver 15 joules of electricity per day. For comparison, a standard alkaline AA battery, which weighs about 0.7 ounces, 20 grams, has an energy storage rating of 700 joules per gram. It delivers more power than the nuclear diamond battery would in the short term, but it would be exhausted within 24 hours. This is insane. Chat, I don't know if you realize how crazy this is, but this is insane. So let's do a little bit of math here. So we have containing 1 gram of carbon, and it produces how much? 15 joules, right? And then here we have 20 grams, and then this produces 700 joules. Okay, this seems like it's significantly more, right? But this is for 20 grams, so we just multiply this by 20. Simple as that. So 20 times 15, by this we get 300 joules, right? We get 300 joules from 20 of this. Basically, honestly, 300 joules is not bad. So if we add up like another 20, right, plus 20, right, and we get 600, that's pretty much the same as this battery, right? Maybe double the weight, but this is literally quadruple the time, you know. This right here lasts for 24 hours. This would last this long, 5,730 years, which is insane. Here it says the battery could be used in various applications, including electronics, medical devices and space travel. The scientist said specific uses include X-ray machines and medical devices that need to operate for a long time but requires low power, such as pacemakers and machines that operate in a difficult and dangerous environments like oil and gas machinery on the seabed. The battery could also be made small enough to power radio frequency tags for identifying and tracking devices and payloads on Earth or in space. The battery, which was built on plasma deposition, has no moving parts and thus requires no maintenance, nor does it have any carbon emissions. So from what they're saying here, I don't think this can be used in phones, because they're saying it needs, so normally phones, I think they take like around 3.6 volts. For example, if you have like a 400 milliamp hour battery for 4500, right, multiplied by 3600 seconds, and we get something in joules, right? I don't know, you get a big number, like something in K's. Okay, so you get like I don't know, 50 something kilojoule. So this is way more than the proposed here, you know, only 20 joules. So I don't know how big they can make it. I don't think they can make it so big, because since it relies on diamond, so like how big can you make it? That's the issue. At least double the weight, but it doesn't produce as much voltage. I think that's the main issue. But you can fix this issue by building a voltage multiplier. Basically take a bunch of capacitors and then you pump out more voltage out of the thing, out of anything, you know. You just need a bunch of capacitors and just make them in a bridge in order to get more voltage from whatever you're making. Okay, so here's what I think about this. From what we have read so far, from all of this stuff, we know that we can now have longer lasting batteries for, let's say, double the weight and for lower voltage. So the take back here is the price. So to produce these batteries, you will need a lot of money, because you're literally using diamond. So yes, it is lab made diamond, but it's still expensive. It's at least more expensive than gold. So you're using these, and we're thinking, okay, so we need double the size of normal batteries now. So double the size of, like, let's say your phone's battery, and then it's like this size, and then you basically add another block to it. Now this is the diamond battery, and keep in mind that all of this is made out of diamond. And from what I understood here, you can't improve the extraction further than this. Maybe you can if you change the radioactive substance that you're using, but so far from this specific substance, if this is the best thing they could find, since they did the research and everything, right? So I'm assuming this is the best thing they could find. If this is the best thing you can use, then the battery is going to be this size, you know, like way bigger than normal batteries. So it's going to be like the size of your phone, but it's going to last forever. So how much is this going to cost? Well, let's see, how much does diamond cost? Okay, how much does so it's around 40 grams. Okay, let's say 40 grams, 30 to 40 grams. Okay, so 30 grams of, we kind of want to double that, let's say 70 grams. How much? Lab grown, 1 carat. Honestly, I don't fucking know. I don't know anything about like gold and diamond stuff. So here it's saying, thus the price could range from around 700,000 to 2,450,000. So I think this invention would never see the light, guys, unfortunately, unless you have 2 million to buy a phone. So yeah, it will never be used in phones. It will only be used for, I don't know, like going to space stuff mostly. This is insane. Oh my god. Kind of want to see the research paper for this. Thank you for the 2 more subscribers to the channel. I really appreciate that. I hope that everyone that watches the video subscribes, because 90%, probably 100% of the people who watches my videos are not subscribed. So if you're not subscribed to the channel, please hit the like button and subscribe to the channel. Thank you for watching, and see you in the next one.